Welcome to this question from the Year 1 AS book. It's exercise 14B, question 8. Okay, now we have here a function f defined as shown there. Okay, and we're told that the tangent to the curve goes through the point 5, E, and we've got to show that it goes through the origin. So 5, E is actually this point here. Okay, they're actually giving us a point on the line. Okay, now we need to know what the gradient of the curve is at that point. Okay, and the gradient, of course, we find by differentiating. Now it is a fact that if f of x is e to a power of x, so it could be e to the kx in general, where k is a constant, okay, then it is a fact that f dashed of x, the differential, is given by k e to the kx. Okay, and that's one of the definitions that you can use, and it's given in the textbook. Okay, so using that, we can see that in this case our k is 0.2. So we can say that f dashed of x in this case is equal to 0.2 e to the 0.2x. Okay, and that's the derivative. And we know therefore that when x equals 5, we can find the derivative. Well, clearly they've chosen 5 or using 5 because 5 times 0.2 is 1. So x equals 5 implies that f dashed of x is equal to 0.2 e to the 1. Okay, I'm putting all the working here. Okay, 0.2 e to the 1 x, well, it's 0.2 times 5, which is 1, isn't it? Just 1. And that's it, so, which is equal to 0.2 e, or if you like, e over 5, which I would prefer to write as a fraction. Okay, so that's the gradient at this point. And then we can just use the general equation for a straight line. Y minus y1 equals m brackets x minus x1. Okay, I'm going to replace the m with the gradient, because basically what we're now saying is we've got a straight line that will come through. I'll do it in a different color here. It's going to come through here. It's going to come through the origin. Let's assume that it does, because they're telling us it does. And it's going to go up through there somewhere, and it's going to cut or touch rather, the curve there. Okay, so that's basically what we're talking about. That's supposed to be going through the origin there. Okay, so let's just conclude that then. So basically we can say now that y minus y1 is the point 5 e, so y1 is e, that's a known point on the line, that's the y coordinate, and the x coordinate is going to be 5, and the gradient is e over 5. Okay, e over 5 brackets x minus 5. Okay, now let's just tidy that up then. So it's in the form y equals mx plus c. Well, y equals ex over 5. Okay, I'm just multiplying this out, minus 5e over 5. I'm just showing every step here. Okay, that's multiplying that out, minus e, plus e, because I'm taking the e to the other side. Well, remember, e is a constant. 5e over 5 is just e, of course. And you'll notice, hopefully, that the constants cancel out. So we get that y equals quite simply e over 5x, or 0.2e to the 0.2 ex. So it's just e over 5 times x. Okay, and that cancels out, plus 0. So a line of the form y equals mx plus 0, I'll put the plus 0 in as well, means that it crosses the origin. Okay, and that's what we had to do. Okay, so we just need to say therefore goes through O. Well, that's it, goes through O, or just maybe put goes through 0, 0. All right, and that's it. Okay.